Welcome guys to the episode 2 of single motor branch circuit complete design calculations. So here we have completed in the episode 1 for the conductor sizing. Now we will do for the overcurrent protection or short circuit and ground fault protection for the motor. Then disconnecting means controller overload protection for motors will follow in the coming episodes. So let us have a review again of our motor feeder and branch circuit. This is our feeder. This is the short circuit and ground fault protection, which we are going to calculate or determine. The disconnecting means here controller and motor. So here in these episodes we will determine the short circuit and ground fault protection. So OCPD or overcurrent protection device or short circuit and ground fault protection. So what are we going to design in this short circuit and ground fault protection? What are we going to determine? So number 1, we have to determine the ampere trip rating, and this is given by the code rules. Number 2, ampere frame if required. Ampere frame can be taken from product catalogs, and also we have to determine the appropriate type of circuit breaker or short circuit and ground for protection. So this also depends on the application. Also number 4, short circuit interrupting capacity. This is the most important to be considered, the CAIC rating of the circuit breaker, because this will determine the correct rating of the short circuit and ground for protection in case of short circuit or fault. And of course, if you have the circuit breaker, we need to know the type of enclosure. So this again depends on the type of application. So what is the code rule for sizing the short circuit and ground fault protection? So for the motor, branch circuit and short circuit ground fault protection, rating or setting for individual motor circuit. So B, all motors, the motor branch circuit, short circuit and ground fault protective device shall be capable of carrying the starting current of the motor. So it should not trip. Otherwise, you are protecting the circuit, but if the motor will not start because your protection device is tripping, then this is not the correct way. It is not the proper way. So setting or rating in accordance with table 430.52, a protective device that has a rating or setting not exceeding the value calculated according to the values given in table 430.52. So the code tells we have to use this table 430.52. And if you want to read for torque motors, it is also mentioned. Now this is the table for 30.52, maximum rating or setting of motor, branch circuit, short circuit, and ground fault protective devices. So as you can see, there are type of motors: single phase, polyphase, squirrel cage, design B, synchronous, and wound rotor and DC motors. Also with different kinds of protective devices: non-time delay fuse, dual element time delay fuse, instantaneous strip breaker, and inverse time circuit breaker. In this case, since our motor is a polyphase or a three-phase motor and is not a wound rotor type, this is an induction motor, so we have to use inverse time circuit breaker. The factor is 250%. So now calculating the short circuit and ground fault protection using the 66 ampere FLC full load current code from the table. 66 ampere times 2.5 or 250%. So it comes out 165 ampere maximum value. So 165 ampere is maximum as per the code. However, checking from the standard ampere rating for fuses and inverse time circuit breaker, we have 150. There is no exact 165 ampere. So shall we use 150 ampere trip, 3 pole, 2 to 5 ampere frame, 15 kaik inverse time circuit breaker? No, we cannot use 150 ampere trip. We can use, however, we have to make sure that the motor will accelerate. That's why he has given 250% of the FLC of the motor. So can we use 175? Can we use the size up rule for this? Because the 165 is already maximum as the code tells. However, we have also a doubt if we use 150. So could be that it will not accelerate the motor. So can we use 175 ampere trip? Let us see. Protection of conductors 240.4b. Overcurrent devices rated 800 amperes or less. The next higher standard overcurrent device rating above the ampacity of the conductors being protected shall be permitted to be used, provided all the following conditions. So the code allows to use the next higher standard rating of overcurrent device above the ampacity of conductors, provided we have to note and follow these following conditions. Number one, conductors being protected are not part of branch circuit supplying more than one receptacle for cord and plug connected portable loads. So this is the number one condition. It should not be part of a branch circuit with a cord and plug receptacle. Why? Because in a cord and plug receptacle, a consumer or a user can plug any equipment, and if there's an overload and your protection is higher than your conductor ampacity, it will not trip and your conductors, your circuit will start to burn without tripping your circuit breaker or protection device. Number two, the positive conductor does not correspond to the standard ampere rating of fuse or circuit breaker. So this also we comply because 165 is not a standard rating of circuit breaker. Number 3, the next higher standard rating selected does not exceed 800 ampere. So this also we comply because our current only is 165 or it is not exceeding 800 amperes. So therefore we can use 125 ampere trip because our circuit is safe. 3-pole 225 ampere frame, 15 kaik inverse time circuit breaker MCCB. So why we use 225 ampere frame? This can be taken from manufacturing catalogs or product catalogs. And 15 kaik, 15,000 ampere interrupting capacity, this is just an assume because as I mentioned in the first episode, we have not yet done the short circuit calculation. So here, just to complete the specifications of the breaker, I am putting 15 kaik, but this is still temporary, or we have to confirm this value. So therefore, short circuit and ground fault protection, we have to use 175 ampere trip, 3-pole, 225 ampere frame, 15 kaik MCCB. But note that this protection doesn't consider short circuit current interrupting capacity kaik, because here a short circuit calculation must be done for the entire electrical system to determine the available short circuit at the motor terminals to be able to select the proper kaik rating of the circuit breaker. Number 2, type of enclosure suitable for the installation. So let us see the update of our circuit design. We have the motor, 30 kilowatt, 380 volts, 60 ampere, power factor 0.84. We have the feeder conductor. We have calculated already the conductor size. And also we have calculated the short circuit and ground fault protection. Now remaining is equipment ground conductor, disconnect switch, motor controller, and the motor overload. So what is in the blank? These are the things that we have to calculate in the next episode. So what's next? Lecture episode 3 about equipment grounding conductor, disconnecting means, and controller. Thank you very much for watching. Thank you for listening. And if you like this video episode, remember my YouTube channel, Einbert Electric. Just click like, click subscribe, and click the notification bell and select all so that you will not miss any of my succeeding video lecture episodes. Thank you and God bless.